Hello everyone, welcome back to LeoAxis Tech, and I hope everyone is doing good. As you know, we started a new series on DNS, Transfer Domain Name System, where we're going to cover the topic in three parts. In the part one, we're going to cover all the foundations, and in the part two, we're going to cover what exactly the DNS and how it is working. And in the part three, we'll try to understand the security concerns and the best practices. So before I'm going to start the part one, on the fundamentals or the foundations, which are prerequisite to understand the DNS, let me tell you what exactly this DNS means first. As you know, DNS stands for Domain Name System. So, why this system and what exactly this system? To make it clear, let me start with a simple story. Let's say this is you. If you want to make a call to your friends, to your family members, or to your colleagues, so what you will do? You will remember all the contacts. Will it be possible to you to remember all the contact numbers for all the devices? Because each contact is unique, right? Each cell phone number is a unique. So will it be possible to us to remember all the contact numbers? No, it is not possible to remember. Okay, not possible to us to remember all the contact numbers. So what we'll do here to overcome this? So in our device, we are using a system, right? In our device, we are using a system or a service which is helping us to store these numbers with a fancy names, right? To store these numbers or to represent these numbers with the fancy names. Now, instead of remembering the numbers, if I type a name, let's say I need to call my friend Navin. So instead of remembering his mobile number, simply I'll type Navin. So now our mobile phone taking the support from this phone book service. Now our mobile phone is asking the phone book service, my dear phone book service, could you please tell me what exactly this name Navin is representing? So now this phone book will help with the number that exactly represented by name called Navin. Now, after knowing the number, our mobile phone will initiate a call to my friend. After knowing the number, our mobile phone will make a call to the particular number. So this is how happening in the real time. In the same way, in the same way, if I want to access any website like LeoAxis, Facebook, Twitter, Amazon Prime, etc., what I'll do, if you observe, all these websites are running in a server. Let's say my LeoAxis website is running inside this server. And here also, over this network where the devices are connected to communicate with each other, these devices are represented with a unique address known as IP address. So this unique address is known as the IP address. And what is the format? We are using IP version 4 format, where it looks like 150.10.2.6. It is just an example of the IPv4 format. Let's say, as I told you, my LeoAxis website is running in this server, and this is the IP address of this server. So what I need to do, if I want to access this website using my laptop in the browser, like Google Chrome, Microsoft Edge, I need to use this IP address, right? I need to open the Google browser. I need to type like 150.10.2.6, right? So then only my request will go to the server, right? The server will take the request, it will process the request, and it will respond back. Okay, it will respond back so that I can see the LeoAxis website page, which is loaded in my laptop. But if you observe in this process. Will it be easy to me to remember the LeoAxis, the server IP address? For LeoAxis, I need to remember like 150.10.2.6. For Facebook, I need to remember like 148.15.10.0. Will it be possible to me to remember all these IP addresses? No, it won't be possible. It's not at all possible to us to remember all the IP addresses. So that is where we are using a fancy names called domain names, replacing the IP address. So to replace the IP addresses, we are using their names to access the websites, which are known as domain names. So in this process, the DNS, the domain name system, so the system is helping us, which is acting like a phone book of this network. It is a phone book of this internet. Just like phone book service in our mobile phones. So this DNS, the system is also acting like a phone book of this internet, which is helping us, which is helping this laptop. Whenever you're searching for a website, our laptop is asking the DNS to get the exact IP address representing this domain name. So the DNS is helping us to get the exact IP address of the server to our laptop. So after getting the IP address, our laptop is initiating a request to reach the server with that IP address where the website is running, right? So that is where the DNS comes into the picture, and it is very, very important to us to understand in detail how exactly the DNS is helping us to get this IP addresses for the particular website. So if you observe, there are the key technical terms and the key concepts that we need to understand to start exactly how this DNS is translating or how DNS is exactly working. So what are the key technical topics or key technical terms that you need to understand? So if you observe here, the key technical terms that we need to understand is what do you mean by client and what do you mean by server. And then what do you mean by IP address? What do you mean by protocol? What do you mean by port number? And along with this, I'll also try to explain two important network diagnosis tools. It is ping and Traceroute, right? So let's cover these fundamentals one by one. So here, we're going to cover these topics using a simple story format, right? First, we'll try to understand what do you mean by this client and server architecture. So this client and server is also known as request and response model. Fine. So to make it clear, so in our story, let's say this is me and I'm feeling hungry. I need some food, right? I need some food. So I went to a hotel and there is a kitchen in this hotel where the food is processed, where the food is prepared and processed. Fine. So here, as me, I can't directly enter into this hotel kitchen. So from this hotel, a waiter, we can also call him as waiter or server, approaches to our table. So I am putting a request to this waiter saying that, my dear waiter, I need so and so dish. So the waiter will take our request to this kitchen. So as per the request, the kitchen will process the food, right? And a processed food will reach to our table from the waiter. So if you observe this story, this is me, I'm requesting the food. The hotel is responding to me with the processed food. And this waiter is helping us to take our request and responds back to the processed food. In the same way, if you observe the story to the technical side, let's say this is me, I'm in front of the laptop, right? If I'm searching for any website like Facebook, like LeoAxis, WhatsApp, Twitter, etc., it means I'm asking to this internet. I'm asking the internet, please kindly get me this website. So I'm initiating the request. Now the internet will take this request to this computer where the website is running. This computer we are called as server. because it is serving to others. It is responding to other computers with its data. So what the server contains? The server contains our website data. Just like the hotel kitchen, how it is storing the food and processing the food, right? In the server also, the website data is stored and it is ready to process that website. So whenever asking the website, the internet will take the request and it will reach to this respective server where the website is actually loaded or actually running. So once the server accept your request, the website is being processed. Now it is ready to deliver to you. So again, the internet will take the response from the server. It will respond back to you. Right? So if you see just like that from the above story, so this is me, I'm initiating the request. So here I'm known as the client. So who is the client? The one who is initiating the request, who is asking for the data. So it may be your device, or it may be your software which is using in order to initiate this request. Maybe your device or the softwares which you are using to initiate this request is known as client softwares or the clients. On the other side, the computer or the server which is responding or which is listening, which is ready to accept the request and responding back to the computers, to other computers. So this computer is known as a server because it is serving to other computers. It is responding to other computers. So it is a responder. So we are the requester. So this model is known as a request response model or client server relationship. Fine. So I hope it is clear what do you mean by client and server. The client is the one who is initiating the request. The server is the computer who is responding to the other computers. That is what. Now we'll try to understand what do you mean by this IP, protocol, and port number with one more simple story. I hope above story is clear to everyone. So let me take one more story here to make you understand what exactly this IP address, protocol, and port number. To make it simple, to make it very clear, let me take you one website. Let's try to search few websites. Then after I'll come back to here. Let's say I'm searching for LeoAxis website. So in order to open the LeoAxis website, so what I'm using, I'm just using the LeoAxis. I'm just using my laptop. In this laptop, in this device, I have opened my web browser and I'm searching for LeoAxis. So I can see this LeoAxis website. If you want to open the Facebook, I simply use a Facebook name so that the Facebook page is loaded. If you want to open any other page, I simply type the name. So the respective website will be loaded. Let's say if I want to open the Instagram, I simply give the name of the website, enter. That's it. So the web page is loaded. So this is how it is working. Fine. So now this device and this software is known as client. So now we are initiating a request. So we are known as a client. Over the internet, the request will reach to the server, right, where the website is located. If you see, our LeoAxis website is running inside this server. So this is our server which is running inside this cloud. And this is the address of the server. So whenever customers are trying to access this server, that request will come into, okay, that request is reaching to this server. Fine. And the server is taking your request coming from the internet and responding back to you. So here, if you see, we are just typing this name in order to get the website. If you see this URL, just copy these URLs one by one. It is a URL for the LeoAxis. If I get the URL for the Instagram, see this address, right? And if you see this URL, so they are the examples of the URL if you want to access the website. Okay, this is how we are initiating the request over the internet. Now let's decode these URLs. What exactly it contains. So if you observe, as I told you, let's say I'm in front of the laptop using my device and using the web browsers like Google Chrome. Now I'm asking for the data for LeoAxis. So I'm putting this request to the internet to get the LeoAxis website data. So here, me or the software which I'm using to initiate this request are known as clients, and the software is known as client software. Right now, how this request looks like? The request is in the format of like this: HTTPS colon to / www.leoaxis.com, right? And if you are trying to open the Facebook, same way you can see this URL like this, right? https colon www.facebook.com. So now the internet is taking this request to the computer where the website is actually running, right? That is what the server, right? Now, if you break down this URL, here in this URL, it contains the IP address or the domain name, the protocol, and the port number. So to make it clear, let me tell you one more story. So in this story, let's say this is me. I'm from Hyderabad, staying in one of the apartments, and it is my apartment address. Fine. Now there is my friend from Delhi who is staying in this area, and it is his apartment address. So it is the address of my friend, and he's staying in one of the flat. His apartment, he's staying in one of the flat. Let's say it is a flat number 101, the 201, is a 301, likewise. And my friend, let's say my friend is staying in the flat number 201. Now, I'm in a situation to send a letter to my friend. Okay. In order to send a letter to my friend, what I need to mention? The first thing I need to mention is address, my friend apartment address. If I mention this apartment address, will it reach to my friend? If I mention only this apartment address, will it reach to my friend? No, because the letter is reaching only to this apartment entrance where the watchman will be available. Let's say there is a watchman. So it means our letter is reaching only to the watchman. But we not mention at all where it should go. So in order to reach the letter exactly to my friend, I need to mention the flat number as well. I need to mention this flat number so that my letter will reach to my friend exactly. If I'm talking to my friend, in that letter I need to mention dear friend, right? If I'm talking to my friend's father, I need to mention some respected uncle or respected auntie. Okay. If I'm talking to my friend's parents, I need to maintain certain protocols, certain rules and regulations. So overall, what I'm trying to say, if you are communicating with someone, we need to follow certain rules and regulations, right? We'll follow certain protocols. We'll follow certain standards, right? Some rules and regulations. So that is how our letter will reach to the exact apartment address, to the exact flat number, and to the exact service. So that is clear to everyone. If you connect the story to the technical side, just like the above story, even in the servers, it is running many services because the server is designed not for a single service. It is providing many services, right? It is running the websites. Okay. It is running the databases. It is running the SSH service, etc. Now, all the services which are running in the server are identified with a logical number. We are identifying these services with the logical number. So that logic number to identify or to represent these services are known as port numbers. So it means to represent these services which are running inside the server, we are using the port numbers. So how many port numbers that are available? So overall, we have the 65,000 plus port numbers that are available in order to represent these services. In that 65,000, we have few port numbers which are already predefined for particular service. For the websites, for the web server softwares which are running the websites, we are using the port number 80 or port number 443. We are representing these websites or web server softwares with these numbers. And for the database, if it is a MySQL, we are using, like MySQL, we are using 3306. If it is SSH, we are representing the service with the port number 22. So like this, we are using the logical numbers in order to represent these services which are running in the server. Okay. Now, this is me. I'm in front of this laptop, okay, using my device. Now I want to access the LeoAxis website where it is running in this respective server. Now, if I want to reach this server, right? If I want to reach this server, just like the above story, if I want to make a request to this server, what I need to mention? First thing I need to mention is address. So that address of the server is known as IP address. That unique address of the server is known as IP address, right? So I need to mention this IP address first. So how the IP address looks like? The IP address looks like, if we talk about the IP version 4, it is in the form of 4 segments: A.B.C.D. Okay, like 152.10.16.230, right? So the IP address looks like in this format. We'll cover this in more detail in the next sessions, upcoming sessions. So if I want to make a request, first thing I need to know this IP address, which is the unique, which is globally unique. Fine. So if I mention this IP address, my request will go till here, okay, till where the watchman or the security guard. We can technically call it as firewall. Okay, so which is attached to this server. So if I mention only the IP address, it will reach, my request will reach till this firewall. But where exactly it is going to take this request? So it means we need to also mention the port numbers. Then only the firewall will take the request to the respective service. So here I want to get this website, LeoAxis website data. So along with the IP address, I also need to mention the port number, the service number, where the service is running. Fine. As I told you in the above story, just giving the address and the flat number is not enough. We also maintain certain standards and protocols. If you're talking with a particular person, right, particular flat number, we also need to talk in a proper protocols. In the same way, if I'm talking with the respective service, right, I need to follow certain rules and regulations. So that rules and regulations are known as protocols. The predefined rules and regulations we need to follow in order to communicate. So that rules and regulations are known as protocols. For example, for port number 80, we are using the standards called HTTP. For port number 443, if you are communicating with the port number 443, you need to follow the standards or the protocol HTTPS. If you want to communicate with the SS service, so this is the protocol which we are using, right? So it means if I'm talking with any port number, I need to also follow these predefined protocols, predefined rules and regulations. So then only my request over the internet, if you provide all these details, then only the request over the internet, it will reach to the server. And if the firewall is allowing your request, then the request will go to the respective service inside your server, and it will respond back to you. So the internet, again, you are getting the response back so that the web page is loaded in your system. And you can see the LeoAxis website. So that is how, if you see this URL also, as I mentioned in the above, our URL looks like this: https://www.leoaxis.com. As I told you, HTTPS, it is a protocol. So it is a protocol to communicate with which port number? 443. Right? It is a protocol to communicate with the port number 443. It means in our request already we had mentioned that protocol and the port number. So what is the next thing now? The next thing should be IP address. But how the IP address looks like? The IP address should be in this format. But will it be possible to us to remember such kind of IP addresses? For LeoAxis, this is the IP address. Let's say this is the IP address of the server. For the Facebook, let's say this is the server IP address where the Facebook is running, and this is the IP address of the server where the Facebook is running. Likewise, will you remember all the IP addresses from all the servers for WhatsApp, Twitter, Amazon Prime, etc.? No, it is not possible to us to remember such kind of IP addresses. So in that case, what we are using, instead of using these IP addresses, we are using these fancy names, which are known as domain names. So instead of IP addresses, we are using the domain names in our system, right? So we are asking the browser, like web browser, like Google Chrome, Microsoft Edge, which is helping us to initiate a request over HTTP or HTTPS. Now we are simply typing the domain name. But the internet requires this IP address. The internet, it don't understand these names. As I told you, the internet, it don't understand these names. The internet only can understand the numbers, IP addresses, right? Then how the request will be possible? How the internet will come to know what exactly is the domain name, which server it is representing? That is where our computer, our system is asking the DNS first. the domain name system. It is asking the DNS. So it is asking the DNS, my dear DNS, can you please tell me the exact IP address of this domain name? But the DNS is helping you to get this proper IP address. The DNS is helping you to get the proper IP address. So once you get the IP address, so now using that IP address, port number and protocol, you are again making a request over the internet. So your request will reach to the server where the website is loaded or running. So that is how it is working in the background. And that is what we need to understand, right? So for every device, there is a unique identity for the network. So that identity is known as IP address, just like the mobile phone, 10-digit number or the vehicle numbers, right? So even for the devices which are connected over the network in order to communicate, so that address, unique address is known as IP address. And in that server, as I told you, there are many services are running, and these services are represented with the numbers known as port numbers. So in our request, we need to mention the IP address, port numbers. And if you're talking with a particular port number, you need to follow the proper standards, proper language, right? If you're talking with the port number 80, you need to follow certain language to understand. So that language, the rules and regulations, if you're talking to any port number, is known as protocols, standards. So this is the format of the request we need to mention. But here, we are unable to remember these IP addresses. So that is the reason we are using the domain names. But the internet is not accepting your names. It must require the proper IP address of the server. So the DNS is helping you to get the proper IP address in the background. So whenever you are initiating a request, like Facebook, Twitter, Amazon, immediately the DNS will get you the respective IP addresses of the servers. That is how it is important to us. I hope it is clear to everyone. Fine. So in this session, we're not yet done. So far we covered what is a client and server. We covered these basic things. Now I'll tell you what do you mean by this ping and traceroute before I'm going to conclude. And in the next session, we're going to cover the part 2 of this DNS series. We're going to cover how exactly this DNS is helping us. How exactly this DNS is helping us to get that names, to translate that names into IP addresses. That is what we're going to understand. So let me conclude this session with the final topic, that is ping and traceroute. I hope so far it is clear to everyone. So what do you mean by ping and traceroute? They are the utilities. What do you mean by utilities? They are the small programs which are designed, so programs which are designed to do a particular task or particular function. What do you mean by this exactly? Let me tell you one more story here. Let's say in our TV, right? In our TV, we have some buttons, right? In our TV, let's say there are some buttons like plus, minus, okay. Next channel, CH plus, CH minus, right? So these are all the buttons that are part of this TV. So what is the purpose of this plus? If you use this plus button, the value will increase. If you use the minus button, the value will decrease. If you use the CH plus, the channel will change. Okay. Likewise, these buttons are designed such a way to do a particular task, right? To do a particular task. In the same way, if you take any system, if you take any operating system, it might be Windows, or it might be Mac, or it might be Linux. So in these operating systems, to support these operating systems, it comes with the utilities, right? So what in the utilities now? They are the small programs which are designed to do a particular task. Okay. As I told you, example, this ping. Okay. Ping is one utility. What is the purpose of this ping utility? The purpose of this ping is to check the network status or connectivity. Okay. And what do you mean by this traceroute or Tracert? You can also call it Tracert. So it is also one of the utility which is part of this operating system, which comes as a pre-installed. And these two are the network diagnostic tools. So the network diagnostic tools or utilities. So using the ping, you can check the network status or network connectivity between the systems. Right now, using this Traceroute or Tracert, you can find the network path. You can find the actual network path. Just like these utilities, we also have utility like ipconfig. If you open your command prompt, okay, if you open your command prompt in your system, and if you use this utility, if you search for this ipconfig, what it will do? It will show complete IP information. So it is also one of the example of the utility which is helping you. So that program, this program is helping you to get these details. So likewise, this ping and traceroute are the utilities which are the pre-installed in our systems, helping you as a network diagnostic tools. So now we'll see what do you mean by this ping and traceroute. First, let me show you what is this ping. The ping is used to check whether the computer or the server is reachable or not. Example, I'm in front of the laptop and I'm trying to check whether this Google server or the Facebook or LeoAxis server is reachable for the internet or not. How to confirm? So in this case, I'm using this ping utility followed by this website name, google.com. Right? Like it is saying like hello to this server and waiting for the reply. If it replies back, right? If you're getting the confirmation or if it is replies back, it means network is working. It means the server is reachable, right? The server is reachable for the internet. If it is reachable, how fast it is responding. It is also check how fast the latency. It also measures the latency, how fast it is responding to us. That is what the ping is helping us. Right? So that is what it is. A network diagnostic tool help us to check the network status of the particular device or the particular server. So with this, we can confirm that yes, this server is up and running. Let's say if it is failed to respond, if it is not responding back to you, if it failed to respond, it means there is a network problem or this server is not running, this server is down. Okay, this server is not running, this server is shut down. Fine, that is all you need to understand. Similar, just like let's say you are making a phone call to your friend. If the phone rings and they say hello, it means the connection is successful. If the phone doesn't connect, it means the connection is failed. Just like that. Okay. The same way, the ping tells whether the server is alive or not. If it is alive, what is the response time? How fast it is replied? Right. At the same time, it is also helping us to understand what is the packet loss. It means if it is replying, what is the packet loss? Fine. Now, if the ping is clear, let me tell you the Tracert or Traceroute. This Traceroute, this word we use in the Linux or Mac OS, right? But this Tracert, this word we use in the Windows. Both mean the same, but because of the differences in the operating system, we use the respective terms, right? Respective utilities. So what this Tracert or Traceroute is helping us? This shows the path your data takes from your computer to destination computer. To destination server. What do you mean by this? Simply, for example, let's say this is me, I'm in front of the laptop, and I want to check this Google server, whether this Google server is reachable or not. If it is reachable, what are the steps it is taken to reach to this respective server of this network? Okay. To make it clear, let's say this is me. If you want to reach to this school, right? So what are all the stops that I need to cross? Like stop 1, stop 2, stop 3, right? Stop 4. And finally, I can reach to this school. So this is the final path. It is the overall path that I had taken in order to reach from my place to this respective school. So in the same way, if you want to know what are the total paths, if you want to know what are the total stops our request passes before reaching the server, if you want to know that, we are using the Tracert or Traceroute. So that is where it is showing the actual path of your data that takes from your computer to the destination server. So example, I'm using Tracert google.com, right? So if I use the Tracert google.com, first it will show my router, then after the next router, then after the request go to the another router. So it will completely show the all the stops, all the paths till it reaches to this server. Till it reaches to the server, it will give the complete path, which router the request is passing. So this path, these stops are known as hops. So hop 1, hop 2, hop 3, hop 4. It means before your request reaching to the server, it is giving the overall path details. Right? It is giving the overall path details. Fine. That is what doing by the Tracert or Traceroute. Now here one thing I need to make clear. As you know, the internet, we don't understand this domain names. Here using the ping or using the Tracert, we are using the domain names. So who is helping us to get the IP address now with respect to server? Again, the DNS. So it is asking the DNS to get the respective IP address. After getting the IP address, it is making sure whether it is reachable or not. If it is reachable, what is the path that is following in order to reach this respective server? In the same way here also, in the ping as well, it is taking the support from the DNS to get the IP address. Then after it is checking the overall, what is the total time taken and whether it is reachable or not. If it is reachable, what is the total time taken? Right? Let me show in practical. So this is my laptop. I'm using the command prompt. I'm using the Windows laptop. Okay, I'm using this command prompt. Right. First, I search for the ping google.com. Yes. See, I'm using the google.com, the domain name. But what the internet is showing, yes, we are pinging the google.com. And this is a server IP address. Right. It is a server IP address. And this is the data. Like just like we are saying hi. Okay, this is the data that we are sending to this IP address. Now, who is helping this internet to get this IP address? Again, the DNS is helping to get this IP address. But will it be possible to us to remember this IP address? No. Right? Simply we can remember the domain names. But DNS is helping us, the system is helping us to get this IP address. After getting this IP address, it is trying to ping this google.com with this amount of data. Right? So what it is happened? So what are the data that is sent to the server? The same data we had received back. That is what the echo. We send the 4 packets of data, we receive the 4 packets of data. It means there is no data loss in this connection. Right? What is the time taken? What is the maximum time taken for the overall response? It is a 19 milliseconds. Right? It is the total round trip time in milliseconds. You can see total is a 19 milliseconds. It is the latency. It means the Google server is reachable over the internet, and it is the total time taken for the response. And it is the amount of data loss. Right? Now let's use the Tracert as well. Because I'm using the Windows, I need to use a Tracert. If I'm using the Linux or Mac OS, I need to use a Traceroute. Right? So because of the Windows, I'm using the Tracert followed by google.com. Let's see what will happen. Fine. So here, if you observe, we'll wait. If you see here, So if you see the each line, like 1, 2, 3, 4, 5, 6. So each line is one hop. One hop means one router, HOP. Okay, one hop means it is representing one router. Okay, the path, the stop before it reaches to the server, right? So total it had taken this 8 stops. So each line representing one hop. It means one router, and it is the details of each router. The first hop is my router, okay, my home router details. And the second hop is the nearest internet service provider router. Likewise. So before it reaches to the Google server, what is the last router details? Okay. So that is what the trace complete, and it is giving the overall path before it reaches to the server. Fine. I hope this ping and trace route is clear to you. Fine. And I hope you like this DNS part 1 series. Thank you for your time for watching this video, and we will see you soon on part 2 session. Thank you all. Take care.